Consider the graph of y equals fx at far right. So we're looking at this graph. From the graph near right, this one, select the ones that best match the following functions. So what we're going to look at is, the easiest way is to look at the first one and then work your way through. We say y equals f at negative x. Now what it happens is, all my x values is going to change sign because it will become minus x. So if I look at my original, and let's say that was negative 1, that x value, if I multiply by 1, it will become positive 1. So this value will move there. Let's get it will become plus 1. If this value was 1, that will become minus 1. And if this value was 2, it will become negative 2. So you can see that this whole thing is just reflected in the y-axis. And that looks pretty much exactly the same as 4. So that was 4. Just going to take that. For the next one, y equals fx plus 3. Now remember, fx is y, so I can say this, all my y values added by 3. So if I now again look at my function over here, if I look at this, all my y values is plus 3, which means that it's going to be moving up. So the whole thing is moved up 3 units. So this, if this was, let's say that was 2, that will become 5. If this value was 1.5, that will, so everything will move up 3 spots, 3 units. So 3 units up, 3 units up. So all of those will move up. Now it's pretty hard to see if we're talking about 2 or 3. What we have to try and look on is 2 and 3 look very similar, but what's going to happen is that this value is always also going to move up, which means that these legs will be a little bit further out on this graph than it is on there. If I look at that distance, I can see that that distance there is a little bit more than that because of the graph moving up, which means it looks like this should be 3. So this will be graph 3. That will be graph 3. Let's just quickly wipe it off. Next one. F is x minus 2. So the x values, remember, is translated into the opposite direction. It's moving in the opposite direction. So it's moving to plus 2. So it's moving plus 2. So all these values is added to. So this one will become plus 2 there. That one will become plus 2 there. This one will become plus 2 on that side. So my graph is going to look like that. Same height, everything. It just moved in the opposite direction of the sign, which is minus 3. And that looked pretty much like 1. So this is 1. If you have to discuss it, you have to say. We'll come back to that last example now. Just want to wipe. In the last question, that must be now 2. So we know that this is now 2. This is 2, but let's just quickly work it through it. Y equals 2fx, which means all your y values are doubled. So this is doubled, so that goes up. If my y value here is 0, remember this y value is 0 and this y value is 0. If I multiply that by 2, it will still go through there, which means my graph will look like this. And that is then the one that is stretched. Or we can say that they stretch into the y direction, and that is why this 2. That's the same as the one there. You need to be able to use the words. So you should be able to say that this function, this one is reflected in the y-axis. Now I'm just going to add that. So we'll say that the graph is reflected in the y-axis. For the next one, which is 3, this one has been moved upwards, so it's translated upwards. So we are going to write the following. Translated up by 3 units. For x minus 2, remember that was a translation, so it's been translated in the y direction. So that graph has been translated 2 units to the right. Our last one is the one that's been stretched in the y direction, and this is what we're going to write. So we say it's dilated in the y direction with a factor of 2. So it's been stretched in the direction of the y-axis in a factor of 2. Very important that you have the wording, not only what it means.